Hello everyone, we are going to be learning about dividing polynomials using synthetic division today instead of long division. So what if factoring is not possible when we are actually dividing our polynomials? Then we use long division, which we've already learned, or we use our synthetic division. So go ahead and write both of those down. Those are either long division or we use synthetic division. Today we're going to be using synthetic division. So our example is y to the third plus 5y squared minus 7y plus 2 divided by y minus 2. So we are going to use this key point right here. The 2, usually if we're using our long division, we would set up our y minus 2 as our divisor, and then the y3 plus 5y squared minus 7y plus 2 as our dividend. So in synthetic division, you always use the opposite sign of that constant. So y minus 2 is actually going to be a positive 2. We're going to draw this little line that looks like this. And what we're going to do is we're going to put our coefficient first. So our coefficient of our first term here is 1. Our coefficient of our next term is 5. So I'm just going down. Luckily, it's already in standard for us, 3, 2, degree of 1, degree of 0, so we have all of them, 3, 2, 1, 0. Then we have a negative 7 and a positive 2. So again, you want to make sure you're bringing those signs with you. To start off, you're always going to bring down your coefficient of 1. You are then going to multiply the 1 by the 2 over here, the opposite sign, so 1 times 2 is 2. You put that multiple there, then the next column. Then you're going to be adding these values here. So 5 plus 2 is 7. Now I'm going to multiply again. 7 times 2 is 14. Negative 7 plus 14 is 7. 7 times 2 again is 14. And 14 plus 2 is 16. Okay, so these are actually this is actually our new polynomial here. So this is again going to be my remainder, and then these are our new coefficients of our new polynomial. We always start 1 degree less than our actual polynomial. So since we started with a degree of 3, we are now going to start with a degree of 2. So this is my coefficient of the y squared term. So I have 1y squared. This is my coefficient of the y, just the regular term, so 7y. Then this is going to be my constant now. So again, we go 1 less. And then my remainder, remember from the last one, we write our remainder as 16 over our entire divisor there, so y minus 2. Alright, so that is our solution to our first problem here. Our next problem, we're going to see that we're missing powers in the actual dividend here. So when we are actually missing powers, we need to put that 0 in to be its placeholder. So when we go through that, we have 8x to the 4th power minus 64 and x to the 3rd plus 3x minus 28. Again, we're going to use the opposite sign of there. So we're going to go ahead and plug in that 8. I'm going to do my longer bar. Okay, let's make sure we are in standard form. So 4. Okay, so my coefficient is an 8 on that one. Then 3, so I do get to use negative 64. Then we're missing the 2. So that 2 is going to be represented, the x squared is going to be represented as the 0. Then we do have a degree of 1 and a degree of 0. So we could use the rest of our coefficients, 3 and a negative 28. Okay, so now I'm going to go ahead and bring down my first coefficient, which is 8. 8 times 8 is 64. Those are actually going to cancel out. I'm left with a 0. It's okay to have zeros. 0 times 8 is 0. 0 plus 0 is 0. And then we have 0 times 8 again. We get 0. 3 plus 0, we get 3. 3 times 8, we get 24. Negative 28 plus 24 is a negative 4. Again, this is going to be my remainder. That last number will always remain as your remainder. We started at the 4 quartic, so now we are going to go to our cubic. So this is now the coefficient of my cubic polynomial. We don't have any x squared, so we don't have any x values, but we do have a constant of 3. So we don't ever write 0x squared because 0 times x squared would just be 0. And then we're going to write our remainder, which is actually a negative 4 with our divisor that we originally had of x minus 8. Okay, so that again is our solution here, making sure that you are placing the zeros in for the original divisor or dividend, what you are actually dividing by, if we are missing any of those degrees. Okay, for our last thing here, using synthetic division to determine our zeros here. So your remainder actually has to be 0 instead. So when your remainder is 0, let's write that in. Your remainder has to be 0 in order to determine the zeros. Remember, your zeros are your x-intercepts. So in this example, it says if f of x, which is just y, is equal to x to the third minus 12x squared plus 27x plus 40, and f of negative 1, so if we're plugging in that negative 1, then that's when we should be having a solution of 0. So then we're going to find all of the zeros of our actual algebraic equation here. So some other problems that you guys might be seeing, this f of negative 1 right here, this is saying that we have, it's actually the opposite, so x plus 1 is actually a factor. So we want to make sure that x plus 1 is going to be the opposite that we'll be plugging in, so it's already in the negative 1 form. So let me show you guys what I mean here. So if I have f of negative 1 equal to 0, that means I'm trying to find my zeros, my x-intercepts. So if I plug in negative 1, this time I will be using that value. But that, again, if I were to rewrite that, it would just be the x plus 1. So on some problems you might see x plus 1 is a factor of your polynomial. So you're going to be, if this is one of them, then you're going to determine the rest of them by using the opposite sign on that. If it already gives you this, you're going to use that negative 1. So I'm going to go ahead and plug in our values. The code, I actually have 3, 2, 1, 0. So we're good to go. So I'm just going to plug in these coefficients here. It's a positive 1, negative 12, positive 27. You don't have to write positive, sorry. And then we have our 40. So go ahead and bring down that 1. 1 times a negative 1 is a negative 1. We get a negative 13. Negative 13 times a negative 1 is a positive 13. Now we're at 40. 40 times a negative 1 is a negative 40. Look at, we got a remainder of 0, so yay, we can actually use our synthetic division to figure out our factors here. So when we do that, we are going to write out the factor I already know is, so we have the x plus 1. We're going to write that factor. Again, I got that from being the reverse of the f of negative 1. So then now I'm going to rewrite my regular polynomial like I have been. This is the coefficient of the 1 degree less than, so this is x squared minus 13x plus 40. So from here, we now have a factorable polynomial. So we want to see if we can actually factor this. The x plus 1 is already factored. The x squared minus 13x plus 40 is not factored yet. I am going to use the AC method because I have 3 terms and no GCF to take out. So since my leading coefficient here is a 1, I know that I can use my shortcut as well. So 1 times 40 is 40. My value, as my b value, is going to be negative 13. What two numbers multiply to 40 but then add to a negative 13? So I know that I have to do 5 and 8, and they both have to be negative here. So my new value I have, so we have x plus 1, and then we have our new x minus 5 and x minus 8. Okay, so these are all going to be our new factors. When I actually solve for these, you're now setting each of these equal to 0, and you're solving for x. These are going to be your x-intercepts. This is just like our regular factoring when we're breaking them down. So I'm going to subtract 1, add 5, add 8, and I know that my factors of my x-intercepts, all my values I'm going to list from least to greatest. So my negative 1 is first, then I have 5, and then I have 8. And again, these are points on your graph. You could write them as points too, where your x-intercept, or your x is going to be the value, your y will be the 0, and that's how you'll also see them as points. And those are your x-intercepts. So again, it's when your remainder equals 0. Some cases you'll be told that the factor is x plus 1. You have one of the factors to find the rest of your factors as well. And then the other one, you're gonna always use the same f of -1. I would actually use the -1 like I just did. All right, you guys, we will get a lot more practice with this in class. So go ahead and write this down, rewind, slow it down, go back, make sure you caught everything, and I will see you in class. Thanks again.